Welcome to this video in my spicy questions series of videos where I look at some of the trickiest exam questions that I've seen in GCSE Maths in recent years. This question is interestingly not from an exam series, so it's from an Edexcel GCSE Maths practice set, and each year exam boards release a few practice papers, and this is from one of those. So this was never actually sat as a real exam. I don't know what the student response might have been, but I've chosen to include this question because I think when people think of laws of indices, they think, oh yeah, I know what I'm doing there. I know when I multiply powers, I add the indices, divide, subtract the indices, and so on. But this is quite a difficult version of that, and it's particularly difficult because it combines two different topics. So you have to work with laws of indices, and then you set up a quadratic equation. You have to solve that quadratic equation and do something else. So there's quite a lot going on. So videos, here it is in big screen. What I would really recommend you do at this point is pause the video, have a go at the question if you think you know what you're doing. If you don't, I'll go through it on the next slide. Pause when you think you know what you're doing, and yeah, give it a go. Okay, right, here's your opportunity to give it a go. Okay, so let's go through. So I know that this is a question that involves laws of indices. The reason I know that is because the base number in every value on the left is 5. And that's a bit of a hint that, well, I should probably simplify these expressions using the laws of indices, because those are all about if they've got powers with the same base, I can simplify the indices. So let's take our first bit on the left hand side, 5 to the power of n squared divide 5 to the power of 6. One of our laws of indices says that to simplify, or when I'm dividing two powers with the same base, I can subtract the indices. So this simplifies down to 5 to the power of n squared minus 6. Right, the next thing on the left-hand side, let's use a different colour, which is 5 to the n squared minus 5n, 5 to the power of n squared minus 5n, divide 5 cubed through same reasoning is 5 to the n squared minus 5n minus 3. Okay, so on the left-hand side, I'm now not multiplying all of that rubbish altogether. Simply, I'm multiplying 5 to the n squared minus 6 by 5 to the n squared minus 5n minus 3. And one of our other laws of indices is that when we multiply powers, we add the indices. So this simplifies down to 5 to the 2n squared minus 5n minus 6 minus 3 is minus 9. Okay, so there we go. Right, so this equation boils down to 5 to the 2n squared minus 5n minus 9 is equal to 125. Now, this is a really common trick in exam questions. You need to be spotting that 125 is a special number. 125 is 5 cubed. So this equation is 5 to the 2n squared minus 5n minus 9 equals 5 cubed. Okay, and because the bases on the left-hand side are both 5, to make these two things equal to each other, the expression on the left-hand side equal to the expression on the right-hand side, well, the powers, the indices, have to be equal. Okay, so the bits highlighted in green have to be equal for that to be true. So ignore the 5s. Let's rewrite this as 2n squared minus 5n minus 9 equals 3. And then rewrite that, because to solve an equation, a quadratic equation, I need to have everything on the left-hand side and just 0 on the right. Okay, so I've now got a quadratic equation I can solve. It says show clear algebraic working, so you can't use any sort of fancy method using your calculator to solve this. I am going to solve this by hand. The way I'm going to do that, now I solve quadratics in a way that might look slightly weird to some of you, but I do it with crisscross. So what I do is multiply the coefficient of n squared by the constant term. So the 2 times minus 12 is negative 24, and then put the coefficient of the n at the bottom, it's negative 5, and I then need to look for a factor pair of negative 24 that sums to give negative 5. So I think that's negative 8 and positive 3. Okay, so they multiply to give negative 24 and add to give negative 5. So I can rewrite my equation as 2n squared minus 8n plus 3n instead of writing minus 5n minus 12 equals 0. Now to factorize these, I take this into two parts, so and then factorize the sort of as much as I can with each of these parts. So the biggest common factor between 2n squared and minus 8n is 2n, and we're left with n minus 4. And then the highest common factor between 3n and minus 12 is just 3, and that leaves me with n minus 4. Now these two sort of sets of things, they both have n minus 4 as a common factor. So if we then factorize out n minus 4, what I'm left with is 2n plus 3. And those are equal to 0. Okay, I've now got two brackets, so I've got two values for n. I've got n equals 4 and n equals negative 3 over 2. At this point, really important to just check, have I actually answered the question? The question is, work out the value of n. Okay, so one of these doesn't work. And the one that doesn't work is given by the condition on the first line that says n is greater than 0. So we have to reject n equals negative 3 over 2. And our final answer is n equals 4 only. Okay, what a sensible thing to do here is to substitute n equals 4 into your expression on the left hand side and check you do in fact get 125, and you do. Okay, thank you for watching. Hope that's a useful explanation of that question. Take care.